蔡英文総統が台湾の半導体産業は世界的なサプライチェーンを破壊しようとする独裁政権の攻撃的な試みから台湾を守るシリコンの盾であると発言したことをひどく楽観的な認識と評しておられます。地政学的なリスクという意味で TSMC を中心とした台湾の半導体産業をどう見ますか？
The Taiwanese government believes that the chip industry in Taiwan does guarantee their security. And the logic behind this claim is that China will be unwilling to put pressure on Taiwan or to attack Taiwan because it's afraid of the economic ramifications. And it's certainly true that if China were to attack, the entire world would suffer economically. China is, of course, the largest importer of chips from Taiwan, and so the implications would be dramatic. But I think history has many examples of countries that have gone to war despite dramatic economic costs. And I worry about putting too much faith in economic rationality to deter China from attacking when the Chinese government has not only repeatedly said that it wants to assert control over Taiwan using peaceful or what it calls non-peaceful means, but it's also built up precisely the military capabilities that might be needed to do so. And so I think when you look at what Chinese leaders say and what they've built up in terms of their military, I think we have to be concerned that they might not be focusing solely on the implications of war for Chinese GDP or for the Chinese stock market. They might be thinking about considerations of national power or of pride or of status. And leaders often make decisions based on these criteria, and sometimes they lead them to bear immense economic costs. And so that's why I'm worried that the Silicon Shield thesis might not be an accurate description of reality, and that China's leaders might be willing to gamble on an attack on Taiwan.
台湾政府は半導体産業を対中外交の切り札や安全保障の武器として活用したことはありますか？
Well, I think the Taiwanese government has been hesitant to use its chip industry as a political weapon. But over the past 5 years, the US government has pushed Taiwan's government to weaponize its role in the chip industry. And in particular, the US has demanded that TSMC and other Taiwanese chip makers stop selling to certain firms, most famously to Huawei, which is now illegal for Taiwanese firms to sell certain chips to. And it used to be the case up until 2020 that Huawei was the second biggest customer for TSMC. Then the US changed its regulations and TSMC completely cut out Huawei from its sales. So although the Taiwanese government hasn't tried to weaponize semiconductor supply chains, the US government has forced it to on a number of occasions.
半導体には多様なハイテクの部品が使用されており、複数の国でそれぞれの部分を生産しているため、一カ国で半導体を生産することは多くの国にとってはまだ現実的ではありません。中国でさえ多国籍サプライチェーン抜きで半導体を生産することはできないし、そのような不可能なことを狙っていないと書かれています。中国は半導体の国際的なマーケットの中でどのようなポジションを確立したいと考えているのでしょうか？
I think to understand China's chip policy, you need to look at the government and the chip companies somewhat separately. China's government wants to have the most advanced technology domestically, but the challenge is that Chinese chip companies are largely private companies that are trying to make money. And most of them realize that for a Chinese chip firm, it's going to be very, very difficult to make money at the cutting edge because they don't have access to the technology that they need. And so as a result, you've seen Chinese chip firms focus not on the manufacturing of the machine tools that are needed to make chips primarily, which is where it's very hard to make money because Chinese firms are so far behind the cutting edge. And instead, Chinese chip firms have focused on chip design and to some extent chip fabrication, where it's easier to have successful businesses, but it doesn't necessarily solve the problems that China faces. And the divergence between what the government wants and what companies are doing, I think, is important in understanding why China hasn't made the progress that its leaders repeatedly talk about.
もし中国が本気で海外の企業の製品を使わずに 自前の半導体を製造しようとしたら、達成までにはどれくらい時間がかかるとご想像されますか？
The question to ask is not how long it will take for China to catch up to 2023 levels of chips, because in 10 years' time, we're going to be 5 Moore's laws ahead of the cutting edge in 2023. So the question to ask is, where will China be in 2033 relative to the cutting edge in 2033? And we know that the chip industry in the US, Taiwan, Japan, and Europe is going to, if past trends prove accurate, have 5 Moore's laws of exponential improvement over the next decade. So I think it's totally plausible that in 10 years' time, China can catch up to today's technology. But I think it's very unlikely that in 10 years' time, China is not only going to close the gap with where it is today, but also to make the progress that that firms outside of China are expecting to make during that time period. And that's what makes catching up so hard. And the problem is that in the chip industry, if you're 10 years behind, you are far, far behind in terms of the computing power you're able to deploy.
今日の中国の半導体産業の抱える問題の一つは、多くのチップが PC やサーバ向けの X86 アーキテクチャと携帯機向けの ARM アーキテクチャを使っていることだが、新たに現在注目を浴びている RISC-V という命令セットアーキテクチャはオープンソースなので無料であるとご説明されています。オープンソースは今後、半導体製造をどう変えていくでしょうか？
I think it's going to change the chip industry in a number of different ways, only some of which are related to the geopolitical dynamics. We already see really rapid adoption of RISC-V architectures in a number of different use cases, from Internet of Things devices to some mobile devices and data center uses. And so from the perspective of the industry, it's a big shift. I think from the perspective of China, it's less influential than some of its backers would like. Even if you can design a cutting edge chip using RISC-V, that doesn't mean you can manufacture it. And today, chip manufacturing in China is critically dependent on the import of machine tools from the US, Japan, and the Netherlands. And China's most advanced chip manufacturers are several generations behind TSMC in Taiwan. And so the specific architecture you use to design the chip doesn't solve your manufacturing problem if you're a Chinese firm. I think insofar as new architectures like RISC-V reduce the cost of designing semiconductors, that's likely to lead to more innovation, more new architectures, more new designs, more new products being attempted in Western countries. And I think that's a good thing. We need to keep the rate of innovation high to keep Moore's law alive and well to stay ahead of China. And so I think rather than worrying about open source, we should actually embrace open source architectures as a driver of some of the trends that have contributed to our advantages.
A 半導体設計大手 ARM とその ARM を買収したソフトバンクの動きについても言及されています。ソフトバンクの孫正義会長兼社長は ARM の成長性を熱弁し、今後数年ARM の成長に神経を集中させると語っています。しかし、ARM を400億ドルで買収したにもかかわらず、売上の全体の5分の1を占める中国部門の株式の 51% をわずか7億7500万ドルで売却しています。これはなぜでしょうか？
I think a lot of the details of the Chinese business's sale remain unclear or disputed. And right now, there's a legal dispute between ARM and ARM China over that relationship. I would say that it remains unclear exactly the specifics of that transaction. We don't know, for example, or it hasn't been publicly disclosed, the extent to which ARM China has long-term ability to sell ARM licenses in China or just over a short term. And so that would impact the transaction value. I think in hindsight, ARM regrets, I would suspect, the sale of ARM China because it's caused a massive legal headache for them. And right now, the ownership and control of ARM China remains a matter of legal dispute in Chinese courts.
中国部門を売却しても、半導体市場において ARM には 大きな可能性がありますか？
I do think so. I think ARM remains at the core of the mobile ecosystem. Phones, tablets are, in many cases, exclusively using ARM's architecture. I think the company has probably done less well than SoftBank hoped when it invested, and the valuation certainly suggests that in part because it faces competition, as you said, from open source architectures like RISC-V, which are competing very effectively, especially for lower cost use cases.
1960年代、70年代、米国の軍需産業の中で半導体は発展し、その後小型化を進めながら、スマホなど携帯電話で大量に使われるようになり、現在は AI の頭脳として欠かすことのできない存在になっています。AI 技術の発展にとってどれほど半導体技術の進化は重要なのでしょうか？
If you want to train an AI system, you need lots of data to train the system, and data requires lots of processing power to make sense of. So, for example, if you'd like to train a computer vision algorithm to differentiate between a cat and a dog, you need to show it thousands and thousands of pictures of cats and dogs so that it learns the difference. And this has required ever more advanced chips to make advances in AI possible. To summarize very simply, our advances in AI have been advances in applying lots and lots of data to systems. I like to think of the question this way. Is it the case that our software engineers have gotten 32 times smarter over the past 10 years? Or is it the case that because of 5 iterations of Moore's law, they've gotten 32 times as many transistors to work with? And I think the answer is pretty obvious. And if you look forward at the trajectory of AI that we've seen for the past several years, and if you project that forward, what you find is that AI is becoming even more data intensive to train, therefore even more reliant on the most advanced chips.
今、様々な製品はインターネットでつながっており、AI を搭載する製品の数も増えてきています。ますます高性能な半導体の需要は高まっていくのでしょうか？
Right, that's right. And I think it's critical to differentiate between training an AI system, which happens in vast data centers, takes lots of time, very energy intensive, very expensive, and then the application of AI or inference, which can take place on your computer or on your phone after a system is already trained. The training is very computationally intensive. The inference or the application is far less so. And so you can deploy, for example, ChatGPT on your computer relatively straightforwardly, but training ChatGPT was an extraordinarily computationally intensive process that took a very long time and required access to some of the most advanced data centers full of the most advanced chips. And so that's the key difference, is that training AI systems requires lots and lots of advanced semiconductors.
経済産業省は2022年6月に台湾の TSMC が熊本に設立した工場に4760億円、同年7月にはキオクシアホールディングスの四日市工場に929億円、米マイクロンの広島工場にも465億円の補助金を出しています。TSMC の CEO は日本国内2つ目の工場建設を検討しているとも語っています。また、この年の8月には名だたる企業8社の出資によって半導体ファンドリー企業ラピダスが国内に設立されました。日本は半導体産業の発展を加速しています。この動きをどう評価しますか？
I think the Japanese government is right to take steps to support the chip industry. Although Japan produces a much smaller share of chips than it used to in terms of the number of chips manufactured, there are still a large number of companies in Japan that play a critical role in chip making and have very advanced technology in doing so, whether that's the machine tools that are needed to manufacture chips or many of the specialized chemicals needed to produce chips. These are areas where Japan has real strengths that it makes sense to support. In addition, I think Japan, like the US, like Europe, like other countries, is also trying to diversify its production. Concerns about over-reliance of Taiwan are part of the driver of why the Japanese government is trying to build up production in Japan. And the entire world benefits insofar as we have a bit more diversification in the production base. So in that sense, I think that the Japanese government's efforts are very reasonable and have a good chance of succeeding.
アプライドマテリアルズ、ラムリサーチ、KLA といったアメリカ企業は、シリコンウェハー上に超薄膜を形成する装置や、ナノメートル単位の血管を識別する装置など、他社が真似できない装置を独占的に製造している。これに匹敵する装置を製造する企業は、他には日本しかないと書かれています。日本の半導体産業の強みは何でしょうか？
One of the key strengths of the Japanese chip industry is indeed the production of these machine tools that are needed to manufacture chips. And we hear more about the companies that make chips like TSMC, but inside of TSMC's facilities, just like inside Samsung's and Intel's facilities, are machines produced by a relatively small number of companies that are capable of moving materials at almost the atomic level to produce the chips that we require. And the most advanced of these tools are made just by a small number of companies. The ones you mentioned in the United States, ASML in the Netherlands, Tokyo Electron in Japan, and just a couple of others. And these companies have really unique capabilities that hardly anyone can match. And they've developed them over the past several decades, in some cases almost half a century. And this is the hardest thing to do in chip making, is make these machines that have the precision necessary to manufacture with accuracy at scale.
台湾の TSMC は長らく世界の半導体市場の頂点に君臨してきました。他の半導体メーカーと比較してどこがそれほど優れているのでしょうか？
TSMC was founded in 1987. They were the world's only company that was focused on simply manufacturing chips. Before they were founded, almost all companies both designed and manufactured chips in-house. Morris Chang, the founder of TSMC, realized at the time that the industry was changing, manufacturing was becoming more expensive, more complex, involved more unique skill sets, and that in the future companies wouldn't want to have to manufacture because it was so difficult and expensive. And so he created a new business model based solely around manufacturing. And as a result, he's been able to serve a much larger community of customers. Today, Apple, AMD, NVIDIA, Qualcomm, all of them turn to TSMC for much, in some cases, all of their chip production. And that's let TSMC grow dramatically. And as it's grown the number of chips it produces, it's benefited from economies of scale that let it drive down prices. And simultaneously, it's learned from the number of chips it produces and is, as a result, able to produce more technologically advanced chips. And there's a relationship. The more chips you produce, the more you can hone your production processes and make more advanced chips. And so it's not a coincidence today that TSMC is both the largest and the most advanced chip maker in the world.
TSMC は今後もずっと強い存在でいることができるでしょうか？
Certainly, they have competition with Samsung and with Intel for the production of advanced processor chips. And although I think most people in the chip industry expect TSMC to do very well, that's not guaranteed. And each one of these companies has to roll out a new generation of manufacturing process technology every year or two with dramatic improvements in quality. And so it's certainly possible that TSMC could make a mistake and slip up. But I think its track record suggests that we shouldn't bet against TSMC. They've got an unparalleled, I think, record in terms of delivering manufacturing improvements on time.
TSMC は半導体製造に特化した最初の企業であるということですが、なぜ台湾政府は半導体事業に特化することの将来性をいち早く見極めることができたのでしょうか？
I would say that the Taiwanese government was correct in the 1960s, 70s, 80s in realizing that semiconductors were a growth industry. The Taiwanese government tried very effectively to attract investment from US firms, from European firms, from Japanese firms into the chip industry in Taiwan. And so that was right. But the key innovation that had made Taiwan a major player in the chip industry was that Morris Chang realized that the business model was going to shift. And that was his realization, not the Taiwanese government's realization. what happened was he had been thinking about this new business model since as early as 1976, according to documents that I've seen from his prior work. And when he left Texas Instruments in the middle of the 1980s, he'd already gotten to know several top officials in Taiwan. And they approached him and said, would you like to start a chip company in Taiwan? Having no idea about this new business model that he was planning to devise. And it was only thanks to the fact that they happened to ask the right person to start a chip business in Taiwan, and that he had been thinking about this business model on his own for almost a decade, that TSMC was founded in Taiwan. But it wasn't due to the fact that Taiwanese government officials were aware at the outset that they were going to create this revolutionary business. Morris Chang was aware, but the Taiwanese government, to some extent, got lucky that he was the person that they asked.
日本はいち早く半導体産業を発展させることに成功し、韓国がやがてこの流れに続きました。日本や韓国は早い段階から国と企業が一体となって半導体産業の発展に尽力したことが成功の大きな要因であったという印象を受けました。半導体産業の発展には国の介入が欠かせないのでしょうか。
I think some amount of government involvement in the industry is inevitable, but I think governments are more capable of playing a helpful role when countries are trying to catch up to the cutting edge. If you look, for example, when Japanese firms were trying to catch up to the cutting edge in the 1960s and 70s, the government played a productive role. When you look at in Taiwan and South Korea, several decades later, when those two countries were trying to catch up to the cutting edge, government played a major role. But when you're at the cutting edge, and your challenge is to assess what technologies and what products will define the industry in the future, that's a question that governments find it much harder to answer effectively. And I think what we've found over the past half century is that companies do a better job than governments at predicting what technologies and what products will be popular and effective next. So I think governments must continue to make sure that their companies face a favorable environment for manufacturing and designing chips, from tax policy to regulation to workforce development. But I think we shouldn't place too much faith on government officials' ability to predict the future of technology, because the history suggests that that's far from guaranteed to succeed. And many of the key shifts in technology and in business models in the past were not predicted by governments. They were predicted by private entrepreneurs who often were able to see ahead far more effectively than government officials were.
アメリカの半導体産業の絶対王者に君臨していたインテルは、今や明らかに足元がふらついており、遅れを取ってしまったと考えられていると書かれています。なぜインテルは大きく半導体のシェアを落としてしまったのでしょうか。
Intel had two major mistakes. The first was that because they were so profitable at producing chips for PCs, and then eventually chips for data centers, they missed several big product shifts in the market. So most famously, Steve Jobs, the Apple CEO, approached Intel and asked whether Intel would like to produce chips for the iPhone. And Intel said no, it didn't sound like a very popular product. And that proved horrendously wrong and cost Intel a lot of money. That was one type of error. Secondly, Intel let its manufacturing technology slip. Over the past several years, it's fallen behind TSMC for a variety of reasons, but I think they boil down to the fact that Intel leadership focused too much on financial metrics and not enough on engineering. And we've seen over the past couple of years, with a new CEO coming into Intel, someone with an engineering background taking over again. And I think that's a positive sign. I think Intel needs to return to its roots in engineering and manufacturing in order to sort out its technological challenges. But at this point, it faces a difficult several years ahead of it, because it's right now trying simultaneously to catch up to TSMC in terms of manufacturing technology, while also trying to shift its business model to adjust to a market environment that is less favorable to the products that Intel produces.
バイデン米大統領は米国の安全保障上の脅威になる企業であるとして、中国の通信機器大手のファーウェイや ZTE に対して新たな機器ライセンスを取得できないようにする法案に署名しました。同様の試みはトランプ政権でも行われました。 なぜ米国はこれほど積極的にファーウェイや ZTE に制裁を加える必要があるのでしょうか。
If you look historically, what you find is that every country that's had access to advanced computing capabilities and advanced telecommunications capabilities, they've inevitably used this for the purposes of espionage, for intelligence gathering, and for military capabilities. And the best example of this is the United States, which we know from the history and we know from the more recent leaks by Edward Snowden, has used its position in computing and telecommunications networks to advance its own intelligence capabilities. And I think if you look back across the history of computing, what you find is that there have been just deep and inevitable linkages between advances in computing and new military capabilities. So, for example, if you look at the first digital computers that were developed in World War II, they were used for code breaking in the UK and the US. Or if you look at the first chips that were invented in the 1950s, they were used for missile guidance systems. If you look at the first supercomputers that were invented during the Cold War, they were used both by the US and by the Soviet Union for intelligence gathering and processing. And so I think it's inevitable that countries will use their computing capabilities, their telecommunications capabilities to bolster their national power. And I think the US, looking at Huawei and looking at the Chinese chip industry in general, was concerned that China was catching up in a really dramatic fashion in a way that threatened US advantages in some key areas of technology, which in turn had undergirded US power on the world stage for the past several decades.
中国の投資会社志向集団が2013年以降、半導体企業の買収を次々仕掛け、複数の米国のチップメーカーにも買収を持ちかけたが、米政府機関対米外国投資委員会がこれを止めました。志向集団は中国の民間企業なのでしょうか。
One of the innovations that you see in the Chinese chip industry over the last decade is that the Chinese leadership, the Chinese Communist Party, has been more creative at using ostensibly private companies that are in reality serving the interests of the Chinese leadership. And that doesn't mean that they're necessarily taking direct orders from Chinese leaders, but it means they're pushing in the same direction of public policy as leaders want. And because they're doing that, they're benefiting from financing from state-owned banks at below market rates. And so there's a relationship between these ostensibly private investors, the party leadership, and there's often close personal links between the leaders of these private investors and party leaders and the state-owned banks that provide a lot of the financing behind them. And so if you look at Tsinghua Uni Group, I think you find a firm that is a private firm to some extent, but it's acting in the interests of the Chinese state rather than its investors. And you can tell that because its investment strategy is not remotely like an investment strategy that would be intended to make money. And indeed, the company has lost billions of dollars over the past several years. And none of its funders, including large state-owned banks or its key investors, ever asked any hard questions because I think they understood that it wasn't really a business. It was really a vehicle for the advancement of China's political goals in the semiconductor industry.
中国による台湾への武力統一の可能性が懸念されています。もしそのような武力侵攻が発生した場合、半導体市場はどのような状況に陥るでしょうか。
Taiwan produces 90% of the most advanced processor chips, and over 1/3 of the new computing power the world adds each year comes from Taiwan. So if China were to attack, all of that production would be knocked offline. The world chip industry would face immense difficulties over many years in bringing additional production online in other geographies, Japan, the US, Singapore, Europe, etc. And in the period in which we tried to bring new capacity online, global manufacturing would face just catastrophic declines. It's not only that we would struggle to produce a smartphone anywhere in the world in the subsequent year, or that PC production would fall easily by 1/3. It's also dishwashers and automobiles and coffee makers and all sorts of other devices that have chips inside, often simple chips, but a new car will have 1,000 chips inside of it. And a not insignificant portion of those today are made in Taiwan. It's possible to produce those chips elsewhere, but only if you've got the facilities ready, the machine tools available, and the workforce needed to do it. And right now, a substantial share of capacity, both of most advanced chips and of less advanced chips, is in Taiwan and could not be easily or quickly relocated.